Hello and welcome back to the straight line section of the higher maths course. Today we are going to look at collinearity. That's exercise 13b from our Lecky and Lecky textbooks. So collinearity, essentially all we're doing here, we are showing that 3 points lie in a straight line. So points which lie in a straight line are said to be collinear. To test if 3 points A, B and C are collinear, we can find out the gradient of AB, find out the gradient of BC, or AC would do as well. And if the gradients from 1 and 2 are the same, then A, B and C are collinear. So here, are these 3 points in a straight line? Well, the gradient of AB and the gradient of BC are equal, so they're parallel, and they have a common point of B in the middle, therefore A, B and C are collinear. When are 3 points not collinear? Well, that will be when the gradients are not equal. So here we can see this is not a straight line, there's a bend in it at point B, so they are not collinear. This test for collinearity can only be used in 2 dimensions, so this won't work in 3D, although we can use vectors to do that, which we will look at later in the course, or you might have already covered that depending on which order you're doing the course in. So here's an example. Show that points P, Q and R are collinear. So find the gradient of P to Q. So again, just use the gradient formula, substitute in the values, and we'll come out with a gradient of 1/2. Find the gradient of QR. Again, use the gradient formula, substitute in, and the gradient's 1/2. So that tells us that those 2 lines are indeed parallel, and because they both go through the point Q, and they're parallel, that means that they've got to be in a straight line, they've got to be collinear. Right, this is a very, 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 very specific statement that the SQA want us to use. The gradient of PQ is equal to the gradient of QR, so PQ and QR are parallel and share a common point Q. Therefore, PQ and R are collinear. So note we're saying that the lines PQ and QR are parallel, and they share a common point Q, therefore P, Q and R are collinear. What we cannot say is that P, Q and R are parallel, because they are 3 coordinates, the coordinates are not parallel. We also, excuse me, we also cannot say PQ and QR are collinear, because they're not, they're parallel. So it's a very, very, very specific statement that we must make. We must make it clearly. Again, you've got to say what you're talking about here. So a statement could read P, Q and Q are parallel and share a common point Q, therefore they are collinear. You have not said that the coordinates are collinear in that statement, so you would not get your mark for that. So make sure that statement is correct 100% of the time when you're working in your jotter, and you will train yourself to write it out properly when it comes to any assessment that you're doing. So you'll not be dropping a silly mark. Right, let's have a look at another one. The points A, B and C are collinear, so we're told they're collinear. Find the value of K. So I'm going to have a look at the gradient of the line AB. So y2 minus y1 over x2 minus x1. So here, obviously, our value of y2 is not a number term, but it's K. But we just substitute in, and we end up with K plus 1 over negative 2. Find the gradient of BC. So again, y2 minus y1 over x2 minus x1, and we end up with 7 minus K over 6. Now we are told that the lines are collinear, so that means the gradient of AB is equal to the gradient of BC. So K plus 1 over negative 2 equals 7 minus K all over 6. So what are we going to do here? I'm going to multiply both sides by 6 and also both sides by negative 2. So essentially I'm just cross multiplying like we do when we're doing the sine rule at National 5. So this comes up here, that goes up there. Multiply out of the bracket here, so we'll end up with 6k plus 6 equals negative 2 bracket 7 minus k. So then subtract 2k from both sides here, and then subtract 6 from both sides also. And divide through by 4 at the end, and we get a value of k equals negative 5. And that is the end of the collinear section. So again, what's important? Make the statement correctly. Make the statement correctly. And also, rather than this being some steps that you take, have a think about what you're doing. If you're finding out if line's collinear, have that picture in your mind. Okay, collinear line, not collinear line. Right, okay guys, have a go at exercise 13b, questions 1AC, 2, 3 and 4.